Hello, this is Mr. Froelich. Today's screencast will be going through pressure centers. So, this is the official start of the weather unit, and we will be gathering weather data from several different sources, including the ones that you see on the screen. This whole unit is designed to break down the process of creating a weather forecast and understanding what the meteorologist is trying to tell you when you watch the weather on the news. So, to understand how all of this comes together, we have to remember that wind itself is caused by uneven heating of Earth, and this in turn will cause differences in temperature and pressure. Now, you've heard me say this a million times by now, but pressure always goes from high to low. The diagram of the simple convection cell from the global winds unit shows how areas with air that is warm that will rise and areas of cooler air will sink. Now, the actual exchange of that air, which is called wind, will not move in a straight line. Instead, it will be bent because the Earth is rotating underneath it, which is called the Coriolis effect. In the north, remember that the air is bent to the right, and in the south, the air is bent to the left. Now, as we move forward with the weather unit, we will really only be focusing on the northern hemisphere because that's the hemisphere where we will experience weather. So to move on, pressure centers themselves will play a huge role into predicting the future weather. One of the things that we need to remember and learn is that the average air pressure is 1,013 millibars. Now, a millibar is a unit that meteorologists use to measure pressure across the globe. Anything that has a unit or number lower than 1,013 is called a low pressure center. Anything that is higher than 1,013 is a high pressure center. So 1,013 is sort of like the magic number. Now, the further away you are from that magic number of 1,013, whether that be lower or higher, will determine the strength of that actual pressure center. So a number that is much lower than 1,013 is a stronger low. A number that is much higher than 1,013 is a strong high pressure center. Each of these pressure centers is going to have distinct features and characteristics that go with it that make it useful in predicting the weather. A low pressure center will spin counterclockwise, again in the north. As you can see here, the red arrows are showing the sort of direction of that wind, and the red L represents the center of that low. When you look at the actual motion of the clouds, you can kind of see how they also show that same motion, that counterclockwise motion around the center of that low. At a low pressure center, air is rising, which creates clouds and precipitation. Precipitation is anything that falls from the sky, so it could be rain, it could be snow, sleet, hail. Any water that falls from the sky is precipitation. Overall, a low pressure center is associated with cloudy and windy weather. So when we see a weather map that has a low pressure center on it and it is nearby a certain location, generally that location will be cloudy, windy, with possible rain or snow. Now I want to note that this picture is not a hurricane. It is a very typical low pressure center that goes over land. And although it looks like a hurricane, it is not. The motion that they have is very similar. A high pressure center will spin in the opposite way, which is clockwise. When you have a high pressure center, that wind is moving very slowly in a clockwise fashion around the center. Air is sinking at the pressure center, which means that you're going to have clear, calm conditions. So generally, the nicer days that you have in a year, the ones where the winds are low and the skies are almost completely clear, are usually from high pressure centers. So it's almost the exact opposite of a low. Now, one of the ways that we can help visualize the actual motion of the winds from high and low pressure centers is to go back to that wind simulator we used last week. Instead of looking at the straight directions of the different wind belts, we are now interested in areas that are rotating either clockwise or counterclockwise, which, as we've already covered, shows a high or low pressure center. First off, you'll notice several areas that are rotating. This one in particular right here is rotating clockwise, which means that this would be a high pressure center. The area up here above Canada is going counterclockwise, which would mean that it is a low pressure center. Now, one of the things you will notice is that areas that have low pressure centers generally have the faster moving winds, and areas that are high pressure centers generally have the slower moving winds. This means that simply looking at the simulation, you can get an idea of how strong that high or low pressure center is based on the way that the winds are moving fast or slow. Now remember, we have already associated windier spots with lows and calmer spots with high pressure, and the actual strength of those highs and lows can be determined by looking at the simulation. So the key thing with the simulation is to help us imagine and visualize the motion of these winds around pressure centers over the entire globe. So one of the ways that we can start to use this information and predict our current weather is to look at a pressure map. Now this map has a lot of data plotted on it, and one thing that I want you to note is that it comes from April 13th, 2020, which means it was the Sunday of our 4-day break this year during distance learning. Now, let's break down the information that you're looking at on this particular map. Every one of these maps will look very similar, and it's going to be filled with lines. These lines are called isobars, which are lines of equal pressure. In reality, these lines are set to be as smoothed out as possible, and they represent sort of like a gradient similar to a topographic map showing elevation. Now, there are several ways that we are going to learn how to read an isobar map like this. One thing that we can remember is that any number that is higher than 1013 will be a high pressure isobar. Anything that is lower than 1013 is a low pressure isobar. So we can start to find high and low pressure centers based on the numbers that are found on the map and places where you get enclosed rings or bullseyes of isobars. So now that we've found a few of these areas, we can plot them with L's and H's. Lows are usually drawn in red and represent obviously low pressure. High pressures will be drawn in blue, and H's represent high pressure. You can look at the numbers that go with this. So 993 millibars for the low, 1030 millibars for the high. Those are relatively far away from 1013, which means these are medium to high strength, high and low pressure centers. The next thing we'll do is we will ignore some of these areas that just kind of seem to stand out. These are computer errors that happen when you are drawing the map, and in future assignments, I will try to find maps that don't have them in there because they can make learning this confusing. After we've identified the high and low pressure centers and using the visualization of the wind simulator from the last slide, we can start to kind of figure out the ways that the wind will move in these areas just based on the high and low pressure centers. So the red and blue arrows here represent the direction of the wind. Now, one thing is you can maybe start to notice that at least around a low, that wind will kind of follow the pattern of the isobars. So usually the circular pattern of the isobars will show the circular pattern of the wind. So the next thing that we can do is we can start to actually identify the weather at different locations using this map. So you already have your winds and your highs and lows plotted, and we can use that to pick certain spots on the map and predict what their weather would be like based on their location. So point A on this map is close to a low pressure center. So if we think back to earlier in the presentation, we said areas that are by a low usually are cloudy and windy. So in this case, since point A is close to that L or low pressure center, we're going to say that it has high winds, probably from the north, and it will be cloudy with a chance of rain or snow or some sort of precipitation. Now we can get that direction of the wind simply by looking at how A is parallel to this location of that red arrow. So our winds are probably coming from the north or northeast. Now, another way to read the strength of the wind is to look at the actual distance between the isobars. In areas where the isobars get close together, those will be areas of very high winds. In areas where the isobars get spread out, those are areas where the winds are calm. So if we pick point B over here in Colorado, or Wyoming, we can start to figure out that since that area is closer to a high pressure center, it will likely be calm and likely be sunny. I can also tell that it'll be calm because the isobars get relatively spread out. The last thing that we are going to cover in this screencast will be information on the jet stream. Now, students usually have heard of the jet stream in the past, but don't necessarily know how it connects with predicting and explaining the weather that we are talking about. So some basics of the jet stream include that it is basically a large belt of really, really fast moving wind that goes around the planet on both the north and south hemisphere. The speeds of this wind can be well over 200 miles an hour, and it is found several miles above the ground. In simplicity, the jet stream can be thought of as a boundary between warm and cold air, and that helps explain different types of weather patterns that will happen as a result of the jet stream. Now, also, it's important to note that the jet stream is essential in creating and moving different pressure centers around the planet. So on the diagram here, I've drawn a couple high pressures and a low. And one thing to note is that the pressure centers that are inside of the jet stream will be moving inside of the jet stream, similar to a boat in water. It kind of gets sucked into the flow of that river and doesn't have a way to escape. Now, a pressure center that's outside of the jet stream is in what we call a holding pattern, which means it will not generally move a whole lot because the jet stream is not able to push it around. Because these pressure centers are moved around by the jet stream, it changes our weather day to day and what makes this week different from next week. So using the jet stream to forecast the weather based on the pressure centers is one of the key ways that meteorologists can figure out what will happen next. Now, one of the things that makes this difficult is that the jet stream itself is also always changing. The jet stream changes speed and direction and flows kind of like a snake around the planet all the time, and this makes using it to predict the weather sometimes very difficult. So let's recap all of this information so we can see how it fits together. Now, looking at a pressure map like this is something that will become easier with practice, and we will be doing this more throughout the unit. Now remember, reading a pressure map boils down to looking at the isobars, which are lines of pressure, and the numbers that go with them. We can find areas of high and low pressure by looking at the numbers and the patterns of the isobars themselves. Areas where the isobars are making circles or enclosed rings are usually areas of high or low pressure. When we find our areas of high and low pressure, we can sort of visualize the way that the wind is going around in those locations. In the northern hemisphere, winds around a high pressure will always go clockwise, and winds around a low pressure will always go counterclockwise. From there, we can start to imagine what will happen to the motion of these pressure centers by implying that the jet stream will move them around. So since we've now been able to figure out what will happen to these pressure centers in the future, we can start to use that information to predict the basic weather at certain spots. We've already figured out that at point A and point B, the weather is going to be controlled by the pressure centers that are nearby. But what we have not talked about yet is what will happen in the future because of this. So in this case, the weather at point A will probably get nicer out because it's getting closer to a high pressure, where the weather at point C is probably going to end up being windier and cloudier because it's getting closer to a low pressure center. Now, taking all of this information and using it at once can be quite complicated. The assignment is going to try to break this down in a way that makes sense layer by layer so that we can use it eventually to predict the weather that we see every day. Thank you for watching the screencast.